Okay, lesson 9.3. Homework is on page 725. So for part A, if you did not reduce the fraction, that's okay. The experimental probability of landing on a 5, 4 times he landed on a 5, 4 out of 20 is just fine for an answer. Is it close to 1/6? Yeah, 1/5 is close to 1/6. Not landing on a 1. So they landed on a 1 2 times out of 20. So that means they didn't land on a 1 18 times out of 20. So that's 9/10. Is that close to the experimental? And they say that is close. Okay, so correct number 2 there. 725. Moving on to 726. And now the lesson. Probability of compound events. Amy wants to pack enough items to create 6 different outfits. She's packing 1 jacket, 3 shirts, and 2 pair of jeans. Can she create 6 different outfits from her clothing items? So they're listing the 1 jacket. She's just taken 1 jacket. Then she has 3 shirts. So they're doing shirt 1, shirt 2, and shirt 3. Then she's got 2 jeans. So they're listing the jeans in the last column. The table is an example of an organized list. What is another way to show the 6 different outcomes or outfits that she could create? You could just write them out, I guess, and just making a different list. You could also draw a picture or something like that. So number 3, describe another situation for which you might want to list all the possible outcomes. Oh, there's all kinds of stuff like making pizza with the different toppings and things like that. 734, the set of all the possible outcomes in a probability experiment is called the sample space. You need to know what a sample space is. You're not always figuring out the probability. Sometimes you just have to list the sample space. So that's what I was doing on the last couple of lessons. Like on 7.2's lesson when I listed heads, 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 tails, tails, heads, tails, tails. That's the sample space. Okay. Organized lists, tables, and tree diagrams can be used to represent the sample space. So look at number 1. The 3 students chosen to represent the class in a school assembly are shown there. There's Adrian, Carlos, and Greg. All 3 of them need to sit in a row on the stage. Use a list to find the sample space for the different ways that they could sit in a row. So if they just use their first initials there. Maybe Adrian's first, then Carlos, then Greg. Maybe Adrian, then Greg, then Carlos. Okay, so that's the sample space. 6 outcomes. This is the sample space. Okay, number 2. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or a hardtop. Use the table or a tree diagram to find the sample space. So here's the table, and then this is what you call tree diagram. This one's kind of wrote out horizontally. A lot of times they're wrote out vertically, so you might see it look a little different than that, but that's okay. So these are the sample spaces. It could be a blue convertible. It could be a blue hardtop. This is the sample space right here. Okay, so letter A. The table shows the sandwich choices for a picnic. Find the sample space. It means you have to list them. Find the sample space using a list, a table, or tree diagram. So pause and go ahead and do that. They're going to take 1 type of meat and 1 type of bread. So right here we have 2 meats and we have 3 breads. So go ahead and list the sample space. Okay, so we could have a ham on rye bread, a ham on sourdough bread, a ham on white bread, a turkey on rye, a turkey on sourdough, a turkey on white. There's the sample space. Okay, a compound event consists of 2 or more simple events. The probability of a compound event, just as with simple events, is the fraction of outcomes in the sample space for which the compound event occurs. Okay, so it's not hard here. We've already been doing this. So if you make a tree diagram to show the sample space, so here is throwing a quarter, a dime, and a nickel. You could get a heads on the quarter, heads on the dime, heads on the nickel, and you would have this heads. I was drawing these out yesterday, so this should look very familiar to you. Okay, so that's an example of the sample space there. So what is the probability of getting 3 tails? Only one outcome has a tails. There's 8 outcomes, 1, 2, 3, 4, 5, 6, 7, 8. So 1 out of 8 is the probability of getting tails. Part B. An animal shelter has both male and female lab retrievers in yellow, brown, or black. There's an equal number of each kind. What is the probability of choosing a female yellow? Show your work in the space below. So go ahead and pause and do that. So we have female yellow, a female brown, a female, I'll write BK for black. Male yellow, male brown, male black. So there's 6 different puppies, it sounds like. So what's the probability of choosing a female yellow? Only 1 out of 6 is a female yellow. So you have to read the question really closely. It says, what is the probability? What is the probability? This 1 out of 6 is the probability. This is your sample space. Number 4, to win a carnival prize, you need to choose one of 3 doors labeled 1, 2, or 3, and then you need to choose red, yellow, or blue box behind each door. What's the probability that the prize is blue or yellow behind door 2? So here's door 2, blues or yellows. There's 2 of them, 1 here and 1 here. And how many different doors are there? 9. So 2 out of 9 is the probability. Go ahead and pause and try number 1, 2, and 3. And it says find the sample space from 1 and 2. So it means you can abbreviate, but write out the outcomes. Okay, a coin is tossed twice. Tails, 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 heads, heads, tails, heads, heads. There's the sample space. A pair of brown or black sandals are available in sizes 7, 8, or 9. So brown 7, brown 8, brown 9, black 7, black 8, and black 9. That's the sample space. Number 3, Gerardo spins a spinner with 4 equal sections labeled A, B, C, and D, and he's going to spin that twice. if letter A is spun at least once, let me change here. At least once, Gerardo wins. So he could just, no matter what, if he gets an A, 1A or 2 A's, he's a winner. Okay. Otherwise, Odell wins. Use a list to find the sample space and then find the probability that Odell wins. Okay. So, could be an A, AB, AC, AD, BA, BB, BC, BD, CA, CB, CC, CD, DA, DB, DC, DD. I'm just going to look here at which one Gerardo wins. Let me get my red color here. So Gerardo is going to win as long as an A pops up. 1, 2, 3, 4, 5, 6, 7. So Gerardo is going to win 7 times out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if Gerardo wins this many times, what's the complement of that? The complement is Odell's going to win, and that's what the question is asking. So the answer to the question is 9 out of 16. Okay? All right. So moving on to the homework page, 737. And if you have time, 738. Thanks, everybody. Have a good day.